All right, I want to look at part 2 of inverse of functions. So we were talking about the inverse of functions up here where we were exchanging the x and y coordinates. There's another way to think about inverse functions. We can verify whether functions are inverses by looking at their compositions. So this is kind of like tying it all together. If we have the f of x and g of x are inverse functions, this is true if and only if the composition of f of x is equal to x, the identity function, and g of x, g of f of x is equal to x, which is the identity function. So let's try it and see. We've got h of x and k of x, and we want to determine whether the following functions are inverses. So again, we want to look at the composition of f of g of x and then possibly of g of f of x. If they both come out as the identity function, then we know they are inverses. So I'm going to pause the video and write this out, and I encourage you, you know how to do compositions, to pause the video and try to do the composition of h of k of x. Okay, so I plugged it in, h of k of x, where k of x is x minus 13 squared. So I took this value and I plugged it in to h of x in place of my x. So I have the square root of x minus 13 squared plus 13. If I was to go ahead and FOIL this out, I'm going to have x squared minus 26x plus 169 plus 13. I can tell right now if I simplify these, I do not get x. So I can stop. I don't even need to do k of h of x because this one's not the identity function. This is not the identity function here. So these two functions are not inverse functions. Okay, so it says verify inverse functions by looking at this one. We've got the volume of a cylinder. The problem says that the formula for finding the volume of a cylinder with a height of 5 inches is volume equals 5 times pi r squared. So this height out here equals 5 inches. It says determine whether r equals the square root of the volume divided by 5 pi is the inverse of the original function. So let's find v of r. So we're looking to see if it is an inverse function. If so, then this should give me an identity. So let's plug it in. We know that v is equal to 5 pi r squared and r is equal to this. So v of r of x, I guess we could say, is equal to v of v divided by 5 pi. Okay, so then I've plugged this in place of my r here. So I guess technically this should be of, anyway, it's fine. So we have 5 times pi times the square root of v times 5 pi squared. Okay, so when I square the square root, those cancel each other out, and I'm left with 5 pi times the volume of, or volume divided by 5 pi. I see those cancel out, and I'm left with v. That looks like an identity, right? We've got the just v by itself. So now let's check it out and see if we get the identity the other way. So we're going to do r of v. Okay, so plug it in. This time we are plugging this in place of v. So I'm going to have the square root of 5 pi times r squared divided by 5 pi. Okay, so my 5 pi cancels. I'm left with the square root of r squared, and the square root of r squared is r. So we ended up with the identity function in both places. V of r is equal to v, and r of v is equal to r. So these are inverse functions. And that is all I have. We're going to do some practice problems. I will post from page 311 and 312 in your workbook. If you have any questions, shoot me an email. Have a great day, guys.